our first program, we have an int-type variable named iNumber. int is short for integer and specifies that the variable iNumber holds an integer. We can name our variables whatever we want, but it is common practice to put a prefix on the variable name, like this I, to let programmers know that the variable type is int. Using I as a prefix is called Hungarian Notation, and you can see the complete table of our prefixes on our Hungarian Notation page. Most of it will not make sense at this point, but you will want to refer back to that page as we introduce new concepts. This first line of code is called a variable declaration and specifies the type and name of the variable that we want to use. In the second line, we store the value 3 in our variable. This is called a variable assignment. In the third line, we output the variable's value to the console window to verify our assignment. In the fourth line, we reassign the variable the value 10 and output the value to the console window again in the fifth line. Compiling and executing the program, we see the expected result. Like variables, constants can hold values too. However, the value of a constant cannot be changed after it is created. Keeping with our analogy, a constant is like a box that we can look into but not change the contents of. Here's our second program. Notice that we have preceded the type int with the word const to signify that this is a constant. Also, we have initialized the constant with the value 3. Constants must always be initialized in their declaration, and their values can never be changed. You might notice that I have added a k to the beginning of the variable name, as well as the I. In Hungarian notation, the k is used to indicate a constant, since the c is used for another purpose. Executing the program, we get this. As I stated before, constants cannot change their values. Adding this line to our program and compiling, for example, will generate a compilation error. Just as boxes with different shapes can hold different kinds of objects, variables of different types hold different types of data. In this program, we introduce double-type variables. Double-type variables like this one can hold numbers with fractional quantities like 1.5. This is unlike the int type, which can only hold integers. The name double is short for double precision, since it has double the precision of the older floating point data type. We will explain precision later. Executing the program, we see this. Finally, we have added 2 more lines of code to demonstrate another method of initializing variables. This initialization uses parentheses and no equal sign. These 2 initializations are basically equivalent. However, there are some subtle differences which we will cover later. At this time, we just want to say that we will refer to these as assignment and constructor notation respectively. Executing the program, we see this.